This is section 3.2, parallel lines and transversals. So in the last lesson, we learned about naming pairs of angles with two lines cut by a transversal. Today, what we're going to do is we're going to say, okay, those two lines are now going to be parallel, so what do we know about angles? So theorem 3.1 is the corresponding angles theorem. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Alternate interior angles theorem, same thing. If two parallel lines are cut by a transversal, alternate interior angles are congruent. Guess what? Same thing for alternate exterior angles theorem. So two parallel lines cut by a transversal, the alternate exterior angles are congruent. The only one that's different is consecutive interior. So if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. Okay, so if you have corresponding alternate interior or alternate exterior, and you have parallel lines, they are congruent. If you have consecutive interior, they add up to 180. So which angles measure 120 degrees? Let's look. So we have the 120 right over here. I know that number 4 is 120 because angle 4 is a vertical angle. We've already talked about vertical angles and how they're congruent. Number 5 would also be because angle 5 is corresponding. Number 8 would also be because 8 is an alternate exterior angle. So those 4 angles, including the one that we were given, are all 120 degrees. And now let's find the value of x. So we are given x plus 5 for an angle down here, and 115 degrees up top left, and then this 4 is just like a label. It's angle 4. So we have to use some of our theorems to figure out, okay, do I add them up to be 180 or are they the same? So there are a bunch of different routes you could take. What I see is that 115 and angle 4 are vertical angles. So that means angle 4 is also 115 degrees. And then I look and I see this angle and this angle are called consecutive interior. Okay, so they're in between the two parallel lines on the same side of the transversal. They're consecutive interior, and I know that that means they add up to 180. So I can write an equation, 115 plus x plus 5 is equal to 180. So x plus 120 is 180, subtract 120, so we get x equals 60. And unfortunately, we're not done with proofs, so let's do a proof. So we're given that P is parallel to Q, and we're trying to prove that angle 1 is congruent to angle 2. So let's fill in the statements. The first one's easy. It's always what's given to us, so we can write that P is parallel to Q. Using the corresponding angles theorem, I see angle 1 and angle 3 are corresponding, which also means that they are congruent. So angle 1 is congruent to angle 3. Now I'm trying to get to angle 2, which is right here, and I see a special relationship between angle 2 and angle 3. I know that angle 2 is congruent to angle 3 because they are vertical angles, and vertical angles are congruent. And then notice I have two things congruent to angle 3, so I can use transitive property or substitution to say that angle 1 is congruent to angle 2.